Hello and welcome to the last video of 6.7, and depending on how I teach this, some years I teach this where I do the test before 6.7, some years it's after. So you may have had a worksheet, you may have had a normal assignment, but here are the answers for 6.6 homework. This is the textbook assignment, and then here are the answers for the worksheet. If we did a day 2 or a worksheet, those are found right here. So I'm just showing both of them because depending on how I teach and go about the year, sometimes I switch this up a little bit. Ignore that page. All right, we're going to be working with graphing linear inequalities in two variables. That means we're going to have an x and a y. So we're basically graphing lines today. And then in the past, what we did is we graphed inequalities with one variable on a number line. Today, we're working with two. So linear equality in two variables is like a linear equation, but instead of having an equal sign, you have a less than symbol or greater than symbol, or less than or equal to, or greater than or equal to symbol. If they ask you to see whether or not an ordered pair is a solution, what you're going to do is you're going to plug in the points into the equation or the inequality, and you're going to see which whether or not it's true or false. So if you plug in these points here, which pair is not a solution? And the reason for there being more than one answer is because there's actually an infinite number of solutions for these types of problems. And I'll get to that a little bit later. So if I plug in 0, 0, 0 minus 0 is less than 6, that's true. If I plug in 6 and 1, I have 6, or negative 1, that makes that positive 3 less than 9. That's 9 is less than 9, that's false. I'm just going to double check the other ones. 10 minus 9 is less than 6, that's true. And then negative 1 minus 6 is less than 6, also true. So it is in fact option B here. Okay, so here is what we are doing. This is the basis of the lesson here. What we're going to do is we're going to be graphing them like we normally would. So if this was already in y equals form, so negative 3 is the y-intercept, 1, 2, 3, down 3, and it goes up 4 over 1. Okay, now instead of drawing a solid line, there's a couple rules. If it's a less than or a greater than symbol, so less than or a greater than symbol, you're going to use a dotted line. And if it's less than or equal to or greater than or equal to sign, you're going to use a solid line. So this one we're going to use a dotted line here. And why we use a dotted line is because if you pick a point on that line, it will make the equation false. So we're saying it's everything up to this line here. It's kind of like using an open dot and a open circle and a closed in, filled in circle when we're dealing with one variable. It's the same concept as that of that. Now, what we need to do is we need to shade. There's an infinite number of points that will make this true, actually. So we're gonna do a test point. So if the line doesn't go through 0, 0, you can use 0, 0. So I plug in 0 is greater than 0 minus 3, and 0 is greater than negative 3. This is true. So since 0, 0 is true, you're gonna shade that region there. So on where 0, 0 is located, into that region. It also says y is greater than, so that means you're shading above. Since it's greater than, you shade above the line. So any point in this region, any point in the shaded region is a solution to the inequality. Okay, and that's all there is to this. So I'll do a couple more sample problems, graph this one here. Since this one's not in slope-intercept form, I'm going to subtract x from both sides. So 2y is less than or equal to negative x. You can put plus 0, but you don't need to put the plus 0. Divide by 2. Y is less than or equal to negative 1/2 x. Okay, so here we're going to start at 0. And we're going to go down 1 over 2. Now this one I'm going to be using a solid line. Oops. because of the equals part. And it says y is less than, so that means you're going to shade below. Now, if you were to use a test point, you can't test 0, 0 here because the line goes through that. You want to use a point that's not on line. So let's test 1, 0. How about 1, 0? If we want to use the testing method. So 0 in for y is less than or equal to negative 1/2 times 1. 0 is less than or equal to negative 1/2. This is false. And here's my test point right there. And you'll notice that that was false and it's not in the shaded region. So that means you've shaded the correct side. Okay, here's another example, and I'm going to go through this a little bit quicker now. 3y is greater than or equal to negative x minus 1, divide by 3, divide by 3, divide by 3. Well, this is kind of an annoying question because the y-intercept is a fraction. Interesting. Okay, so negative 1/3. It's going to be approximately right about there. Now I'm going to go up, or I'm going to go down 1 box over 3. So I'm going to go down 1 over 3. And notice how I'm not, this is one of the first graphs where we've seen where the y-intercept is a fraction. But we can still handle that because our slope is still down 1 over 3. So you're noticing I'm not right perfectly on the whole numbers there. And greater than or equal to, so I can use a solid line. And greater than, which means I'm shading above. Now 0, 0 this line doesn't cross 0, 0, so that means I can use that as my test point. So 0, we'll plug into the original equation. 0 plus 0 is greater than or equal to 1. That is 0 is greater than or equal to 1. That is false. And you'll notice here, what did I do wrong? Oh, it's negative 1. Okay. Okay, I was like, oh, I thought for a second there, because the 0, 0 is my test point. That's right there. And I was like, something seems wrong. That is true. And I shaded into that region there, so I did it correct. Got scared there for a second. Okay, you can graph inequalities in one variable too. Okay, there's going to be either a horizontal line. These are the x equals, the x is greater than, or the y is greater than. Those are what I'm talking about, where you just have an x or a y in them. So I'm going to do 2 examples here, and these are really quick actually. Y is less than or equal to 3. So we just go down to negative 3. That says 2. Let's fix that there. I'm just going to get rid of this line here. I don't know why that's there, because it's wrong. And start out over there. Okay, so we're going to go down to negative 3. And then that is going through the y-axis only. It's a solid line, not a dotted line. And y is greater than 3, so you can just shade above. And that's all there is to it. And then x is less than negative 1, go to negative 1. Only goes through the x-axis. This one's going to be a dotted line. And x is smaller than negative 1, so less than, so we're going to shade to the left. And that's all you do for those guys there. Here's a word problem. I think I'm going to go over this word problem with you guys in class. I always like to go over word problems as a class discussion, just to kind of talk through all of the information we have here. So with that being said, I'm going to leave you guys with this assignment, and we'll go over that word problem when you guys get to class. Thank you for tuning in to the final section of chapter.